In this example, we're going to use Dijkstra's algorithm to find the shortest path from vertex A to vertex I. Now, to begin our journey, we have to begin at A. We can get there in 0 because that's where we're starting. So that's the first vertex to be added. Now that that's in our solution, you need to consider all the vertices that we can now connect to. We can connect to B, D, and C. We can get to B in 23, D in 56, and C in 39. Now what we do is we pick the lowest, which is of course B. So that's the second one to be added. So that goes in there. But now we've got to keep focus. Now that B is in our solution, we can now connect to E and D. You've got to make sure that you consider all the edges which are leaving B. So we can get to E for the first time in 23 and 27, so 50, and we can get to D via a different route in 23 and 28, so that's 51. That does represent an improvement. Now we take a step back and we look at all these numbers here and we pick the lowest one, so 39. So that's the third one to go into our solution, and we stick there. We keep our focus very much on vertex C, and we just consider now all of the vertices that we can now get to, namely those three. Now D doesn't represent an improvement. If you add those two numbers up, that gives you 59, but perhaps the 39 and the 44 we need to consider, because we are connecting to F for the first time. So there we get 83. And H we can get to there in 83 add 40, 123 minus 1, 122. Take a step back now, and you're just trying to focus on all of the vertices which are not connected. So all of those on the right hand side, and the lowest number there is of course the 50. So that becomes the fourth one to enter our solution, and we can now connect to D via a different route, although it's not very helpful because we're not going to beat 51. So that didn't do a lot when that got entered into the solution. But looking at these three numbers now, we're looking at 51 being our next vertex to permanently get added. So there we go, and there are quite a few things to consider. Well, there's two things, G and F. G for the first time, so we can get there in 88. F via a different route, and we can now get there in 72. So we're looking at the 88, the 72, and the 122. Clearly F is going to be the next one to be added, so we put that in there. That's the sixth one, and we've got quite a few things to consider. We get to G, I, and H. G is not going to be, sorry, it is going to be a slight improvement. We're going to get 87, so that does improve things. We can get to I in 72, let's add the 4, 76, add the 40, 116. I'm just going to check that actually, is that right? 72, 76, 76 add 40 is indeed 116. It's definitely worth checking if you feel you've gone wrong, because one mistake can throw the whole thing. Although you are allowed calculators, of course, in D1, so I would recommend that you use them. Now we need to consider H as well. We can now get to there via a different route, slightly quicker. We can get there in 99 there, which is actually quite a good improvement. So I've acted on all those three vertices which could connect from F there, and now I just pick the next lowest, 87. So that's going to be the 7th one to go into my solution, and I permanently label that as 87. There's just one thing to consider, and that's now the I. We can now get there in 88 add 20, so 108, which is an improvement. And then we pick the lowest of the 108 and the 99, so that's the 8th one to go in there, 99. Just one thing to consider, which is the only vertex that's not yet permanently added, and we're going to do 99 add 20. It's not an improvement, so 108 will be the shortest length. But do label this up here. 108 is the shortest length. To actually determine the root, of course, what we need to do now is work backwards. Now we know it's not going to go down here, so if you recall, we've just discussed that that's not going to be the solution. So we need to think, how did we get there? Now 108 minus 21 does equal 87, so we must have gone to there. And then 87 minus 15 does equal 72, so we can go down there. 72 minus the 21 does give us 51, so we can go up to there. 51 minus 20 doesn't work. 51 minus 56 doesn't give us 0, so hopefully 51 minus 28 equals 23. It does. And then 23 minus 23 equals 0, so that's the route that we went there. Just label this as A, B, D, F, G, I. And then if you want to give an explanation, just use some arithmetic, just display what we did there. If you start with 108 and you minus back 21, then that gives you the 87. So then we can conclude that GI is in the solution. I'm just going to take a photo of what's above. And then we were on 87, and because when we did 87 minus 15, because that gave us 72, we could conclude that edge FG was in the solution, and then 72 minus 21 equal to 51. The conclusion being that DF is in the solution, is part of the shortest path. 51 minus 23, apologies, 51 minus 28 equals 23, therefore BD is in the solution, and then 23 minus 23, as trivial as that might look, do put that in, equaling 0, therefore AB is in the solution.